Okay, we're going to start Unit 4, Lesson 9 here. We'll start off with problem 9.1. What we want to do is we know that we have a triangle that has side lengths 3, 4, and 5, and it is a right triangle by the converse of the Pythagorean theorem. What we want to know is we want to figure out what are the measures of the acute angles. So before we start that, let's go over here and look at our right triangle table. And just to review a little bit, remember that the adjacent leg divided by the hypotenuse, we called that the cosine of the angle theta. The opposite leg divided by the hypotenuse, we called that the sine of angle theta. And then the opposite leg divided by the adjacent leg, we called that the tangent of angle theta. So these are our three ratios that we use in trigonometry. So to the problem, we know we have a right triangle with legs 3 and 4 and a hypotenuse of 5. So we can sketch that out. There's our right triangle, legs 3 and 4 with a hypotenuse of 5. We will start first with this angle. We'll call this angle theta. And we want to figure out what is the possible measure of that angle theta. So if we come over here to our right triangle chart, we can choose any one of these that we want. Usually, it's just out of habit, I usually go with the opposite and the hypotenuse. So with angle theta, the leg of 4 is the opposite leg, and the hypotenuse has a length of 5, and I know it's the hypotenuse because it's opposite the right angle. So now I can set up my trig function. I know the sine of some angle is going to be equal to the opposite, which is 4, divided by the hypotenuse, which is 5. So I know the sine of this angle is 4 divided by 5, which is 0.800. So now what I need to do is I need to look on my table and figure out where is the opposite over the hypotenuse. I'm looking at this column. Where is that value around 0.800? So I see that it's right down here. So angle theta must be some angle between 50 and 60 degrees. Now I do the same thing for my other acute angle. Here's acute angle. We'll call that angle alpha. I'm going to do the same thing. I know that the sine of angle alpha is equal to the opposite, which is the 3, is opposite angle alpha, divided by the length of the hypotenuse. And again, the hypotenuse stays the same. So I know my opposite is 3, my hypotenuse is 5, so then I know that the sine ratio for angle alpha is equal to 3 divided by 5, which is 0.600. So now I come over here and I find, where do I have a opposite over hypotenuse, same column. Where's the opposite over the hypotenuse equal to 0.600? And I see it's here, somewhere between, I know angle alpha must be somewhere between 30 and 40 degrees. Now notice, it doesn't matter whether I used sine, as I did here, or I could even use tangent, opposite leg divided by adjacent leg. So let's try tangent of, let's make that a little thicker. And let's try tangent of theta. Now the opposite theta is 4. The adjacent theta is 3. Right? If this is my angle theta that I'm talking about, opposite over adjacent, 4 over 3. I'm looking for a tangent ratio that is around 1.33. So I come over here to the opposite and the adjacent column, and I look for 1.33, and notice it's still between 50 and 60 degrees. So just a little reminder of how to use our right triangle chart. On the next video, we're going to show you that we don't even really need the right triangle chart, and better than that, we can figure out exactly what these angle measures are.